Welcome, my friends. In this video, we will be covering section 8.6, Independent t-test. In this section, we discuss the independent t-test, which is a hypothesis test to see if there's a difference in the population mean of two independent populations. Similar to the paired t-test, we will have three different options: the left-tailed test, the right-tailed test, and the two-tailed test. For the left-tailed test, we will have this set of hypotheses. The null hypothesis will be that the two means are equal to each other, and the alternative will be that the first population mean is less than the second population mean. We will be finding a p-value in the left tail of the distribution. You should use this setup when you believe that the first population mean is less than the second population mean. For a right tail test, we will have this set of hypotheses. The null hypothesis will be the same, but the alternative will now have a greater than sign, and we'll be finding a p-value in the right tail of the distribution. You should use this setup when you believe the first population mean is larger than the second population mean. Finally, we have the two-tailed test, which will have the same null hypothesis, but the alternative will be that the first mean is not equal to the second mean. In this case, the p-value is the combined area in both tails of the distribution. You should use this hypothesis test setup when you believe that there's a difference between the two means, but you're not sure which one is larger. Here is the test statistic for the two-sample mean test. Due to the calculation-intensive nature of the test statistic and the degrees of freedom, we're going to be using the TI-84 calculator to complete this test. The above formula is what the TI-84 uses. In addition to the complexity of the test statistic, the degrees of freedom are actually very complicated. Typically, the degrees of freedom have been the sample size minus 1, but in this case, we actually have two different samples, one for each population. So it turns out to find the degrees of freedom, you would have to use this very complicated formula. So to skip all this, we're going to be using the TI-84 function to complete the test for us. Similar to all the other hypothesis tests that we've done in this class, we will be following the Phred technique. The F in Phred stands for formulate the problem. And for an independent t-test, this includes describing the two populations, describing the two samples, describing the quantitative variable, describing the first population mean as well as the second population mean, and setting up the null and alternative hypotheses. The R in Phred stands for review conditions. For an independent t-test, this means that the data from each sample should be roughly symmetric or only slightly skewed. Also, the data from each sample should have relatively few outliers relative to the sample size. These were the same conditions that we used when we were doing the one-sample confidence interval for the mean as well as the paired t-test. The best way to check these conditions is to create a box plot of each of your two variables, as well as perhaps a histogram. In the execute calculation step for an independent t-test, we're going to be using the two-samp t-test option on the TI-84. We will also make a decision to either reject or fail to reject our null hypothesis in this step. Finally, we will draw conclusions, which will involve writing a statement using this template. At the alpha % level of significance, there either is or is not enough evidence to suggest our alternative hypothesis. Let's look at an example. Grand Valley State University instructor Luke Ellison, me, wants to test to see if his students are performing better in Stat 215 than his rival instructor, Lauren Berry. Luke and Lauren each decide to give the same exact final exam to their students and compare the results. Luke has 108 students, and the mean exam score was a 79.02 with a standard deviation of 18.88. Lauren has 78 students, and the mean exam score for her was 74.00 with a standard deviation of 21.97. Test Luke's claim at alpha equals 0.10. First, we must formulate the problem. Before we do that, I'm going to write down some of the given information so that we have it. Luke has a sample size of 108 students, so that's N1. His sample mean is 79.02, which is X bar sub 1. And the sample standard deviation is 18.88, which is S sub 1. For Lauren, the sample size is 78, the mean is 74, and the standard deviation is 21.97. Let's go ahead and formulate the problem. The first population includes all students who theoretically could take Luke's Stat 215 class, and the second population includes all students who theoretically could take Lauren's Stat 215 class. The samples include the 108 students from Luke's class this semester and the 78 students from Lauren's class this semester. The variable we're collecting is the final exam score out of 100. mu sub 1 is the population mean exam score for all students who theoretically would take Luke's Stat 215 class, and mu 2 is the population mean exam score for all students who theoretically could take Lauren's class. Next, we must set up our hypotheses. Recall that the null hypothesis and the alternative hypothesis both relate to mu sub 1 and mu sub 2. Our null hypothesis is that mu sub 1 is equal to mu sub 2, always, for the independent t-test. The alternative hypothesis is going to have one of three signs, either a greater than, a less than, or a not equal to sign, depending on what we are trying to test. If we read the first sentence, it says that Grand Valley State University instructor Luke Ellison wants to test to see if his students are performing better in Stat 215 than his rival instructor. So that means we're trying to test that Luke's mean is higher than Lauren's mean. So we're going to have a greater than sign in our alternative hypothesis. Note that there is a difference in the sample means. The sample mean for Luke's students is indeed higher than the sample mean for Lauren's students. But we would like to do the independent t-test to see if this is a big enough difference to conclusively be able to say, at the 10% level of significance, that the population mean score for Luke's students is higher than that of Lauren. Let's go to the next step, which is review conditions. Now in this case, we don't have the data to plug into the TI-84 calculator, so we can't really make the box plot. But I did have the data in the background, and I have created comparison box plots for us to see. So if we look at the data, we can see that the data is slightly skewed, a little bit more so for Lauren, because we have maybe a little bit more outliers here. And there's also only a few outliers, which is not really that significant compared to the sample size. Recall the sample size is 108 and 78, and we only have one outlier or two outliers, which is not very large compared to the sample size. So we'll say we have met the two conditions. Next, we can go ahead and execute calculations. And we can do this by following these steps on the TI-84 calculator. So here's my calculator. And I'm going to go to Stat, Test, and ToSample t-test. Stat, arrow over to Tests, and then I will choose the option 4 here for the ToSample t-test. Now you have the option for either data or stats. And depending on the problem, you will use one or the other. In this problem, we do not have data. We did not put numbers into our stat list. But in some cases, you might be asked to do this. In this question, we have statistics. So we can go over stats and press enter. And that's going to prompt us to enter in all this information over here. So we have X bar 1, which is 79.02. We have S1, which is 18.88. We have N1, which is 108. We have X bar 2, which is 74. We have S2, which is 21.97. We have N2, which is 78. Then this is going to ask us for our alternative hypothesis, which is greater than. So we're going to hover over the greater than and press enter. We will always choose no for the pooled option. There's actually two different versions of this test, and choosing no means we are not assuming that the standard deviations are equal in the population, which is typically the more common result and the more conservative approach. We can go down and we can calculate. And we'll get a bunch of different information here, which I have copied down over here. So we can see that these numbers are the same. We can see that the calculator has outputted the test statistic, which came from that formula we showed earlier in the slideshow. It also gives us the p-value of about 0.0526. It gives us the degrees of freedom from that big nasty formula, as well as a couple of other things that we really just inputted into the calculator. So as a reminder, we have a right tail test. So that p-value is really the probability in the right tail of the distribution. Really what this p-value is saying is if there truly was no difference between Luke and Lauren's, teaching styles and average grades in the population, then what would be the chance of observing the results that we have, basically like a 5-point difference here, or more extreme? Well, it looks like there's only about a 5% chance of that happening if there really was no difference. So relatively unlikely. And the way that we eventually make our decision is we compare that p-value to the level of significance, the type 1 error rate. And in this case, the level of significance is, the p-value is lower than the level of significance. 0.0526 is less than or equal to 0.1. So you may remember the saying, if the p-value is high, the null will fly, or if the p-value is low, the null has to go. In this case, the p-value is low. It is lower than the level of significance. So the null has to go. So we are going to be rejecting the null hypothesis. Okay, finally we can do the draw conclusion step, which really just amounts to filling in that template statement. So that conclusion will be at the 10% level of significance, there is enough evidence, since we rejected the null hypothesis, we say there is rather than is not, to suggest that, and then we need to describe our alternative hypothesis, which is that mu sub 1 is greater than mu sub 2. Mu sub 1 is, of course, the population mean final exam score for Luke students, and we have enough evidence to suggest that that is higher than it is for Lauren students. And that completes the independent t-test. All right, here's a problem for you to try. Among music majors, do pianists or violinists practice more hours per week? The weekly practice from a random sample of 12 piano performance majors and 9 violin performance majors at XYZ University is shown below. Is there enough evidence to suggest that either piano performance majors or violin performance majors practice more in the population? Use a 0.05 level of significance. It is this statement right here that is giving you the alternative hypothesis. So make sure you use that when you're on that step. So go ahead and complete all 4 steps of the Fred technique. All right, that's all I had to talk about in this video, so I will see you in the next one.